So for number 13, when it says f of 0, that means take 0 and substitute it into function f. So function f is 2x squared minus 3x plus 1. So I'm going to set it up like this. Instead of 2x squared, I'm going to put parentheses squared. Okay? Instead of minus 3x, I'm going to put minus 3 parentheses and then plus 1. So anytime you're going to evaluate, you should start by replacing all the x's with parentheses. So function f looks like this. And of course, this 0 is the thing that we need to substitute in for those x's. So I'm going to have 0. So if you evaluate this by hand, like you should, then, well, 0 squared is just 0. 2 times 0 is 0. So I'm clearly just going to get 0. Minus 3 times 0 is 0. And then plus 1. So all these zeros, I didn't really even have to write them down. Okay, so the net result is 1. Okay? So there's that. If I were going to use a calculator at all, you know, you got to show your work, but I'm just saying you could do this. Hold on. Just understand what your calculator will do. You know, I could have typed this into the calculator if I were allowed to. And we're verifying that we get 1 that way as well. Anyway, so that's the answer for number 13. 1. Okay, moving on. Sometimes they ask you to show the answer as an ordered pair. As an ordered pair, this would be 0, comma 1. You know, the 0 is coming from that, and then the 1 is coming from your answer. So this is how you would write it as an ordered pair. Now, number 14. Again, we're doing 2x squared minus 3x plus 1, but this 4 means we're going to put a 4 in there. Okay? Parentheses, exponents, multiplication, division, addition, subtraction. This is your order of operations. So exponents come before multiplication. So you have to be careful to do your exponent first. 4 squared is 16. Okay? So fine, we did our exponents. Now we will do our multiplication. So 2 times 16 is 32. Okay? 3 times 4 is 12. All right? And now I can do my addition and subtraction. 32 minus 12 is 20. Okay, so then I've got 20 plus 1. So that's 21. All right, so that's the answer. As an ordered pair, it would be 4, comma 21. All right, is another way to put it. All right, again, you could type all this in your calculator if you were allowed to use your calculator and get your 21 that way. All right, but for now, you're supposed to do it by hand. Okay, how about number 15? So, still using that same function, so 2x squared, what was it, minus 3x plus 1. But this time we're putting in the negative 3. Okay, so let's do our exponents first because of the order of operations. So we have to square this first. So negative 3 squared is positive 9. Okay, negative 3 squared means negative 3 times negative 3. A negative times negative is a positive. So please make sure you put a positive 9 right now. Okay? Watch out, because if you put negative 3 squared in your calculator, it's going to tell you negative 9. All right? But it's not doing what you think it's doing. If you really want to do negative 3 squared, then you have to put it in parentheses. Okay? And then you'll see that it is positive 9. Without parentheses, it's only squaring the 3 and then sticking the negative sign on it. And that's not what you wanted. So it should be a positive 9. Now here we have negative 3 times negative 3. That is a positive 9. And then your plus 1. Okay, you know what? I usually do that on another step. Okay, I'm just going to copy this down for right now. All right, now I'm going to do all my multiplication. So this is 18, and like I said, this is positive 9, and then positive 1. Okay, add all this up, right? So this is 27, and then plus 1. So the final answer is 28. Or as an ordered pair, you could do -3, comma 28. Once again, if I were allowed to use my calculator, I could type it in this way. And then there's your 28 that we got. Okay, how about number 16? All right, so one more time. F of 2. So again, this is 2x squared minus 3x plus 1. So now we're evaluating at 2. All right, let me just double check. 2x squared minus 3x plus 1. Okay. Do your exponent first. All right, you must square this first. So this is going to be 2 times 4 minus 3 times 2 plus 1. Now do your multiplication. So this is 8 and minus 6 and plus 1. Now do your addition and subtraction. 8 minus 6, well, that's 2. 2 plus 1 is 3. So your answer is 3, or as an ordered pair, you could write 2, comma 3. Okay? One more time, notice I could type this into the calculator if I had been allowed to use my calculator. And there's the same 3 that we got doing it by hand. But as far as this assignment, you must do it by hand, no choice. Okay, let me show you one more thing as far as the calculator goes. The table feature. Please understand that we could have gotten all 4 of those answers at one time using the table. So if you were doing some sort of a standardized test, this is what I would prefer that you do because it's more efficient. Type in your function. So we had 2x squared, so let's type that in. And then we had minus 3x plus 1. All right, let me just double check. 2x squared minus 3x plus 1. Okay, so put this in your table, use your table feature. Okay, we hit enter. And then, so for example, problem number 13 started at 0. So right now, it's where it says start, we'll just make that a 0. Hit enter like 4 times. Okay, so 0, f of 0 is 1. Okay, so there's the 1 that we got. For number 14, we're supposed to find f of 4. So I could just scroll down to 4. F of 4 is 21. Okay, and sure enough, we had 21. All right, take a look at number 15. We're supposed to find f of -3. Well, we could just scroll to -3. -3, f of -3 is 28. All right, same thing we got. And finally, number 16, we're supposed to find f of 2. So we could just scroll to 2. And f of 2 is 3. And that's what we got. Okay, so know how to use your technology so that when you're allowed to use it, you'll be ready to go. All right, let's keep going with number 17. Let's analyze this. This is a parabola. All right, it's quadratic. It's in vertex form, so we should be able to look at this and immediately know the vertex. It's the opposite of the inner number, and the outer number stays the same. So this should be positive 2, comma 4. The opposite of this one, comma this one. Let's put that vertex in the middle of our chart. So let's put our 2, 4 right here. Based on the fact that there's a negative in front, a negative a value, we know that this parabola is going to be a downward facing parabola. So we can go ahead and just write down right now. Because it's a downward facing parabola, we know that the vertex is going to be at the top. It's going to be a max. All right? I want you to see how you can know all of these things before you even graph it. The axis of symmetry. We already know what the axis of symmetry is going to be. It's going to be x equals 2. The vertex sits right on the axis of symmetry. So the axis of symmetry equation will always match the x value of your vertex. Okay, for the rest of it, let's go ahead and make the table in the graph. So for the other x values, let's go less and greater. So less than 2 is 1 and 0. Greater than 2 is 3 and 4. All right, let's just use the TI-30XS multi-view. So table function. All right, so we're going to have negative, open parentheses, okay, x minus 2 squared plus 4. Okay, so I've got x minus 2 squared plus 4. Hit enter 5 times. Okay, now we need to start at 0, so scroll if you need to, but mine is already at 0. So I've got 0, 3, and 4. So I've got 0, 3, and there's the 4 that we knew we would have. Now because of the symmetry, if this is 3, then this should be 3 on the other side. If this is 0, then this should be 0 on the other side. Now let's check it against the table. There's the 3 that we expected. There's the 0 that we expected. If those numbers ever turned out to be not balanced, you should look back and try to find your mistake because you did something wrong. Okay, so we've got these values. Let's graph them. So 0, 0 is the origin, so that's right there. And then 1, 3 is next, so 1, 3. 2, 4 is next, so 2, 4. And then that's where the symmetry started kicking in, mirror image, mirror image. Now, looking at all this space down here so far, I'm betting that we can fit another point on this graph, another pair of points, I should say. So this is mandatory. You should always look to see if the next value will fit. 5, -5 fits nicely. So let's graph it. 5, -5 would be right here. And we can also graph its mirror image, which would be right here. Okay, will another value fit? Nope, it goes to -12 after that. And that's, the graph only goes to -10. So this will have to do. Let's go ahead and draw the parabola. So your parabola should look very much like that. Make sure it goes all the way to the edge of your graph. Definitely don't let it stop. Don't just draw it like this, dink, and let it stop way up there. That's definitely messed up. All right? You should use 7 points because they fit instead of just 5. And even beyond that, you should go all the way to the edge of your graph. Don't forget to graph your axis of symmetry as a dotted line. All right, so there's your axis of symmetry. Now let's go back so the axis of symmetry is a vertical line. Vertical lines always have the equation x equals something. So you see that we have a vertical line at 2. So it makes sense that it would be x equals 2. All right? Do not just put 2. It has to be x equals 2. Otherwise, it's not a line. Now the zeros. The zeros are x-intercepts. Okay, so the zeros, I'm going to redo them in purple real quick. The zeros are right here, these purple places. Okay, they are the x-intercepts of the graph. Okay, so that is 0, 0, and 4, 0. The y-intercept. The y-intercept is always 0 comma something, because the y-intercept is where the graph touches the y-axis. Well, in this case, the graph touches the y-axis right here. So this is both an x-intercept and a y-intercept. So 0 comma 0 is the y-intercept. Now the domain. The domain is the x values of a graph. So it's how far left it goes and how far right it goes. All right, this graph goes left forever and right forever. So that's negative infinity to positive infinity. Okay, now the range. The range is the y values of a graph. So that means how low does it go and how high does it go. And it has to be in that order, bottom to top. So how low does this thing go? Well, it goes down forever, so you should be thinking negative infinity, okay, down here. How high does it go? Well, this is the maximum height right here. That's 4. So it's this graph goes from negative infinity to 4, and it has to be that order, bottom to top. It's got to be least to greatest. Okay, so the range was negative infinity to 4. Infinities always get the round parentheses, but this 4 should get a square bracket. All right, that bracket means that 4 is included on the parabola. All right, the parabola touches 4. You can see the 4 when you look at the vertex, 2 comma 4. It's right there. That point is included on the parabola. Okay, so that is it. All right, that is all for problem number 17. All right, looking at number 18. Please understand that this is your A and this is your B value. It's the C value that's 0. We know that this is B because it has the X. The X term is the B term. That's important because when we are dealing with standard form, if we want to find that vertex, we're going to use the formula opposite of B over 2A. This will give us the axis of symmetry, which will also give us the x value of the vertex. So opposite of B, so that's negative 4 over 2A, so that's 2 times 2. All right, so that's negative 4 over 4, so that's negative 1. Okay, that is the axis of symmetry. All right, so you can go ahead and write x equals negative 1. Make sure you put x equals, not just negative 1. But that's also the x value of the vertex. Okay, so we know it'll be negative 1 comma something. Now, to get everything else, let's start by putting that negative 1 right in the middle of our table. The other values should be less than negative 1, negative 2, negative 3, and greater than negative 1, 0, and 1. To get the y values that go with them, let's put this in the TI-30 XS multi-view. So hit your table button, and then what do we have here? 2x squared plus 4x. So 2x squared plus 4x. Okay, where do we want to start? Let's start at negative 3. All right, I could have just scrolled there. But either way, make sure your table is starting at an x value of negative 3. So I've got 6, 0, negative 2. So I've got 6, 0, and then negative 2. Okay, now, because of symmetry, I'm expecting that the other two y values should be the mirror images of these. So I should find another 0 and then another 6. But let's check and see if that's true. Okay, there's the other 0 I was expecting, and how about the 6? Bam! There it is. All right, so that lets us know that we are doing the right thing. So let's go ahead and graph these values. So we've got negative 3, 6. So there's negative 3, 6. I do have a tape measure. There's negative 3, 6. All right, so then we have negative 2, 0, so that's going to be right there. Ciao. And then negative 1, negative 2, so that's right there. And then that's where the symmetry kicks in, so kabam. All right, I have a feeling no more points will fit, but we should always look. Oh, sure enough, the next one's at 16, that's off the chart. So we will have to make do with these 5 values. So let's go ahead and graph the parabola. All right, so there's your parabola. Make sure you draw it all the way to the edge of your graph. Now, do not forget to draw your axis of symmetry as a dotted line right down the middle. All right, so there's your axis of symmetry. Now, let's answer the rest of these questions. So the vertex turned out to be negative 1, comma, negative 2. Now, this vertex, because it's at the very bottom of the graph, we know that it is a minimum. Clearly, this parabola is reaching for the sky. So this is facing up. We knew it would be upward facing from the equation because the a value is positive. We already had the axis of symmetry, but now that we look at it, yes, it is a vertical line at negative 1. Thus, x equals negative 1. Now the zeros are the x-intercepts. Okay, so the x-intercepts are here and here. So that's negative 2, comma 0 and 0, comma 0. The y-intercept is where the graph touches the y-axis. Okay, so the y-intercept is going to be this purple guy right here. 0, comma 0 is where the graph touches the y-axis. The domain is the x values of a function. So how far to the left does it go and how far to the right does it go? Well, left forever and right forever means negative infinity to positive infinity, all right, with round parentheses. Now the range is the y values. So we're talking about how far it goes from bottom to top. And it needs to be in that order, bottom to top. Okay? So this is the bottom of the graph right here. And here's the top of the graph. Well, at the top it goes up forever. So the range is going to be from negative 2 to positive infinity, bottom to top. Okay, and the negative 2 will be in a bracket. Okay, the square bracket means that the negative 2 is included. It's part of the parabola. And in fact, you can see that negative 2 when you look at the vertex. Okay, there's the negative 2 right there. All right, I think that is it for number 18. Okay, make sure you have your range in the right order. All right, I'm going to go ahead and stop the video right here. We still have a few problems left on this review. So you can catch these review problems simplifying exponential expressions on the next video. I'll see you on the next video.